founder and director based in India. In the past, I worked with NetSquare, Chase Bank, IBM, and Foundstone. Pretty much I'm interested in web security research and such. I published a lot of papers, books, and advisories. Whatever tools we are going to cover today, you can download from googlefi.com/tools.html. Today's agenda is we'll start with web services and how it plays in this Web 2.0 era. .NET Web Services assessment methodology, we'll see footprinting, discovery, enumeration, fingerprinting, attack vectors, how you can scan and fuzz web services. And finally, we'll look at .NET Web Services defense methodology, how you can do port scanning and secure coding, and how you can put web services firewall. There is a content filtering in place for this. So this is our entire agenda for today. Companies are investing in web services. There is something published in McKinsey 2007 Global Survey. By the end of 2007, 30% of large companies will have some kind of a Web 2.0 based initiative up and running. This is a recent Gartner's finding. And by 2008, web services or SOA would surge ahead. So this is clearly saying that the web services stuff is picking up. It is around for last 3 or 4 years, but it's never started to pick up. But as soon as this Web 2.0 stuff started to kick in, this stuff is started to pick up. If you look at some of the pages, for example, you look at the page flags, or you look at the start.com, live.com, all these pages, if you look at their architecture, it will look like something like this. You have a browser with Ajax, RIA, Flash-based application, HTML, JS, DOM, etc. sitting. You will connect to internet, and then you have web services piece and local application running with a database and all. Through web services, it is connected to weather, news, documents, email, bank and trade, RSS feeds, etc. So you're like a one page, you can see a lot of different things. So if you go to the Google/IG, you have like a lot of widgets which you can plug into your home page, and then you can browse around and such. So this is essentially a piece where you have a web services which is directly talking with the Ajax or RIA based calls in the front end. In your browser, it is making a backend call to the web services. If you look at how web services get consumed, you have a browser layer. I usually divide the entire communication channel into these 4 sections. You have a browser where Ajax, Flash, RIA, HTML, widgets, JavaScript, DOM, etc. sitting. Then you have structures like XML and JSON. Like in the past, we have like a simple GET and POST request going back and forth with the parameters equal to ampersand and such. Now we are seeing a lot of our protocol. These are the 4 popular protocols with XML web services: JSONRPC, REST, XMLRPC, and SOAP calls. And then you have a server-side component which is either sitting in services, open APIs, or SaaS framework. So this is how like entire web services get consumed in your browser. The methodology which I follow for assessing the web services, you have an insecure .NET Web Services. Then there are 2 approaches which I take. One is a black box where I do footprinting and discovery. Then I do enumeration and profiling. I do vulnerability detection. And on the white box, I do code and configuration scanning. You have a secure coding, put a web services firewall, and you have pretty much secure web services in place. So this is the methodology by which I do assessment, and a lot of tools which I have written are on the basis of these assessment methodology. We'll start with footprinting and discovery. Objective is to discover a web services running on application domain. For example, you are assessing one of the application, how you can identify what kind of a web service is residing on a particular application or application domain. For example, if you look at the traditional application, you have hrefs from where you can identify various different resources. But over here, what you have is you don't have href. It's like an Ajax script which is making backend Ajax calls, or RIA or Flash-based application which is making Ajax calls. So this makes the entire discovery and footprinting process very innovative nowadays. There are 2 approaches which I take, or 2 methods. One is a primary discovery where you actually crawl or spider. You do script analysis or page scrubbing, or you do traffic analysis and try to identify. So you are actually hitting the site and try to get the handle to a web services. The another method which I follow is something called a secondary discovery. what you do is you go to a search engine, query it, and try to identify what kind of a web service is running on particular domain. Or you can do a UDDI scanning. That is a protocol, XML-based protocol by which if an entire domain or entire application domain is running with a UDDI server, then what you can do is you can query UDDI server and try to identify what web services it is running with. Primary discovery, crawling the application and mapping the file. So what you can do is you can crawl the application, and for example you're looking for .NET Web Services, look for a .asmx extensions. These are the extension. Another thing you can do is do page scrub, JavaScript scrubbing and such, and try to identify paths, try to identify backend calls and such, by which you can identify. Or what you can do is you record the entire traffic, and from traffic you identify the patterns for JSON or XML. So from that you can identify this particular resource is serving you JSON or XML stream. Primary discovery, what you have is a page scanning with graph, look a JavaScript for URL and path. That is a one way you can do. You can do a crawling, simple crawling. Or if you are running in the front end, you are usually like a backend web services is ASMX. The front end is running with the Atlas framework of Microsoft. So you can scan for Atlas. The tools which I have for this is one, you can use scanweb2.o, which you can download. There are toolkits which I have written with 5 or 6 Ruby script by which you can try to identify what web service is running at the back end. And then there is a tool called URL grab. So it will go to the page and try to grab the URL. So I will show some demonstrations. Okay. Over here, first I'm going to show you the footprinting and discovery with the page. So over here what I have is pageflex.com page. When you hit to the pageflex.com, what you have is you get a one JavaScript, that's it. And then entire page is created from these JavaScript, one JavaScript. So what I'm doing over here is I'm just saving this page locally. Page is saved. Now what I'm doing is page is downloaded. Now I'm just running the command and running the command on all JS file. So I run the command on full JS script, and I did an egrab with ASMX extension, and I found these many web services running at the back end. So if you look at the PageFlex page, almost 10 to 12 different web services, .NET Web Services are running at the back end. So if your crawler is crawling the page, it's not going to identify these resources, because these entire resources, set of resources is bundled in the JavaScript. So if your crawler or automated crawler smart JavaScript grabbing, then it will find these URLs, else it won't find. So this is the one way I can identify, this can be a start point for me to attack each one of these ASMX files. Each of these ASMX files is a web services, .NET based web services. Second thing is definitely you can spider or crawl the site. So over here I am simply crawling the site. Got this particular web services. So this particular page is running with a web services, or on this particular URL there is a web services. But it is important that if someone has already put this web services as href, then I'm going to identify this web services. If it is in bundled in JavaScript, then this methodology will not work. The previous methodology would work. The third is, here is a fetching from Atlas. For example, here is a login page where I'm entering my username and password credential. Login over on a Firefox, you can see it has sent a JSON stream. It has sent a JSON stream back to the server. Now, if you go for a scanweb2.o, there is a script called scan Atlas, where I'm looking for Atlas-based references in it. So now I'm running the scan Atlas RB and running this particular script. So it will go and grab the backend ASMX file which is using. So over here I can identify it is running with the trade.asmx page. So what I'm doing is, as soon as I get the HTML page, I try to run certain patterns, regex patterns, and try to identify what backend service it is running with. So this is another way you can discover the backend web services. The fourth one is you can do a URL grab, where there are few large regex pattern which I have made, by which I try to run through the JavaScript and try to identify different resources. So over here I can identify Atlas-based resources. So these are the four methods which essentially a primary discovery, where we are hitting the site and identifying the resources. The other method is you can do is with the Google discovery or MSN discovery. This is a little tool called WS Scanner, where I'm doing Google discovery. I'm applying Google API key. I want to identify how many web services are running on Amazon.com. So I'm entering domain patent or a patent Amazon.com. Over here I'm selecting domain and then I run the tool. So this will make the backend API call to Amazon.com, and there is a large file type check which I am making. I'm looking for ASMX, I'm looking for WSDL. There are like list of things which I have made with URL and file type, and I get all the web services running on Amazon.com domain. So like entire Amazon.com domain, whatever web services are running, I fetch from Google services. Over here I've selected Microsoft.com, all the web services running on a Microsoft.com. Even you can run a pattern check. So you are looking for a web services where Amazon Word is there. So this is essentially a secondary discovery we are making. Primary discovery, we are hitting the site. In the secondary discovery, we are not hitting the site, and straight away identify these resources. So this is the way essentially we have discovered in Footprint all the .NET based web services running on particular domain. Once we are done with that, I would go for secondary discovery, looking for ASMX, and WS Scanner can help you. You just have to register for Google key, take the Google key, punch in into this tool, and it will identify all the different web services. The second part of it, following steps, you have to fingerprint .NET framework and client-side technology. There are various different type of client-side technology running with like a Dojo or Atlas or such. So you have to do a client-side technology scan. And second, you have to do a scanning on WSDL. WSDL is the ASMX file has a WSDL. WSDL contains certain critical information like looking for methods, collecting input or output services, and query web services or invoke web services. And then you have to capture these method signatures. So over here, first I'm doing profiling and invoking through proxy. So what I'm doing over here, this is a demo site where I have a web services running over here. So this is the access point for web services. So this is a web services I'm running with. You have a vulnerability scan. So I scan the vulnerability. Now over here you can see I've given a ASMX WSDL endpoint, web services endpoint, .NET web services endpoint to the tool. It downloaded the entire WSDL file and made a profile for me. So this is a web services profile for me. So this particular web services has following four methods: intro, get product info, get rebates info, get security token, and it has following input and output. So I get the entire map for web services. So now I know like which parameter or which method I want to attack. So then in the next step I can go ahead and look for, so these are some of the critical WSDL tokens or WSDL XML tags which I am looking for: operation which map to methods, or I can go for a binding points which maps to the endpoints. So here are the list. Following methods are supported. So then I can invoke this web services. So there is another the tool called WS proxy, where I start listener and I select the get product info method and I invoke it. So as soon as I invoke the method, I get the SOAP message. So this is the SOAP message for web services. At the ID node, I enter 1 and I get the first product information out. So this is the way I profile entire. I selected one method. I moved to my next section. I started my listener to see what kind of a SOAP traffic gets generated when I invoke this particular method. I invoke get product info method. I got the entire SOAP message here. Now I can manipulate the SOAP message. I just entered 1 and I got the first product ID over here. So this is the way you can profile, and then you can invoke your web services, .NET based web services. Something called scan Ajax. So what I'm doing is, this is a Ruby script where Ajax fingerprinting I'm doing. So if you give the URL which you want to fingerprint, it will go out and run the script, and following here is a list of popular framework like Dojo, the WDR, Moo, Rico, Yahoo, XAjax, Atlas, etc. It will look for these prototypes. So it will say that this particular site is in the front end, it is running with this framework. So over here you can see it is running with the Atlas fingerprinting framework, Atlas runtime.js. So I did a server-side fingerprinting. I identify server-side fingerprint, and I identify server-side entire web services profile, and then I did a client-side stuff. Once I'm done with this, I can move to next section. Once we have this, then we can map what different kind of risk associated with .NET Web Services. For example, there are in-transit risk, in-transit sniffing or spoofing, WS routing security concerns, replay attack vectors. Web services engine level, you have buffer overflow, XML parsing attack, spoiling schema, complex or recursive load can be injected into your SOAP message or XML message. Denial of services, you have a large payload, you can break the service. Web services deployment policies, customize error, leakage, authentication and certification issues. And finally, there is a layer where web services code has been implemented by a developer, so it has a parameter tampering, WSDL probing, SQL LDAP, XPath, OS injection, virus spyware, brute force, data type mismatch, content spoofing, formatting, etc. Next is, we want to scan this entire web services. So what can invoke the method and temper the parameter. For example, instead of one, try to go for a single quote, double quote, etc. Typical application scanning stuff which we are doing. Or you can do auto audit, where define different vectors which you want to perform on your particular web services and do. Or you can do a fuzzing web services stream, XML or JSON stream, which you can fuzz. What you can do is, you can fuzz the stream, and then you look for the response patterns. You look for a fault codes, 500 and fault codes. You look for enumeration fault strings. You look for dissecting XML message, or look for a JSON stream where you have a different messages are bundled in. Let's see one of the demo over here. First is parameter tampering. On a WS scanner, what you can do is, you can go ahead and go for a dollar sign instead of ID. So it's generated. Now I'm going for, say, double quote. So in ID string over here, I'm injecting double quote, and I got a 500 internal server error, and then I can see the entire stack of web services. So over here, I have received an entire stack of web services where it is saying that some kind of SQL error is over here. So this is a possibility of SQL injection over SOAP with ID parameter, we are saying. So this is the way you can identify some of the vulnerabilities, or you can perform some of the tests. Second thing what you can do is, there is a web services as a audit has a feature called WS audit. So what I'm doing over here is, I'm selecting different attack vectors which I want to perform on my web services. So data type, SQL injection, LDAP injection, XPath injection, attack string if I want to go for 1 or 1 equal to 1 or something like that. So I can inject all of these strings. Over here, I select pattern on the entire response, then I can select over here and put that particular file as my regex file, and finally I run the entire audit. So whole audit, all different tests would be automatically run, and you can see different parameters were injected in the place of ID, and I got the entire response back. So this way, automated fashion, you can check your web services. Another thing which I stream or on a JSON stream, there is a WS fuzzer over here. You can define your target. I'm defining my payload, which I want to, or a fuzz load. Here is a pattern which I want to check. So I want to look for 500 or fault code or such. This is my fuzz load. This is my patterns. once I go for it, over here I write first, whichever parameter I want to first, I just say hash first hash. So whatever entire my payload will be replaced for each one of these requests will be replaced by at this particular place, and entire fuzzing will start. So you can see the red wherever the pattern is found, 500 or fault code, it will show me in the red, and some of the vectors get executed. So you can collect this fault code, and from a .NET code, there is a lot of enumeration. You can see there you can find some places you can find the internal paths, or you can find internal SQL or a column error or such. So this is how you can identify the stuff. Another interesting thing is in the same thing, what you can do is you can define entire JSON stream instead of XML stream, and in the JSON stream you can say $, first $, so it will first the JSON stream instead of XML stream. So this is web services. Next, we'll just check top 10 web services or top 10 Owasp and compare it with the web services. First is cross-site scripting. Access is possible through web services. It would be DOM-based access via eval call, because Ajax is making a backend web services call, and then once he has the entire stream back, it will eval the current DOM context. So this is where eval can be poisoned by incoming XML stream. Another thing is you can do a JSONRPC based stream coming through a browser, inject into a DOM, or you can have a source stream can be coming from a third party, because over here what you are seeing is you are connecting to the target application. It may be a large mashup since it is taking information from a third party and pushing in your SOAP envelope. So this is a way you can have a source stream coming, or this is the one where access is over with JSONRPC. So what I have over here is, for example, you have application where there is a small mailing application where you are seeing different messages, 1, 2, and 3 messages over here. If you look at the page source, it is actually calling the get JSON profile 1, 2, and 3. There is a function, and this is the Ajax call going to the backend. Once the Ajax response comes, it will do eval, and once it is eval done, it will do a document.write, and then that stuff will come out. And over here, it is sending the JSON string. So it is bundling the JSON string, taking the parameter coming from a function in ID, and sending it to the server. So this is the way Ajax call is talking with a backend JSONRPC. There are various different .NET DLLs available, which you can plug in into your application, and it will become a JSONRPC, or you plug in and it will become XMLRPC or such. It's like a Cook's library which converts your normal program to XMLRPC, where you just have to define a header and then you put the code in between.
You have 5 minutes just to let you know. We can probably push a little bit. But
Sorry?
So there's only 5 minutes left scheduled. We can probably push a little bit since
Message has been sent with ID 1, and then you have a hello message. Then you go for the third message, and you have access, because in your stream, in your JSON stream, you got the script tag, which is getting injected into your eval call. So this is a first attack. Then you have injection. Over here, what I have is, say for example, SQL Injection. So here is the tool where in a SOAP envelope I just put ID 1 or equal to 1, and it is the SQL injection over SOAP. Then malicious file execution. Inject different values like a pipe and a command or such. So malicious file execution would be possible. You can go for insecure direct object referencing, where you // or // over SOAP envelope you pass // and it will do that. For example, over here a file access call. So I select get rebate. I go for foo. There is a file info. This is a parameter going through to the backend web services. And over here I got the entire bundle of error block, which is suggesting that path C, inetcom, rebates, file info. So I do that slash dot slash and try to fetch the entire source code from the system. So I get the entire source code over here. Cross-site request forgery, CSRF with XML stream, XMLRPC or a SOAP-based system. We are making the backend call to the web services, and it is possible to generate XML stream from a browser form, and one can attack the XML stream with the XSRF. We have like a traditional XSRF where just the post or a get request hit to the backend services. Over here, what I'm going to show you is like how form, and then it attacks the backend services. So for example, we go to the service over here. There is a form. What we are doing over here is we are authenticating. John user is authenticating on the server, and it is putting a request for 20 stocks on this particular system, and PC.NET based call, and order is placed to the backend services, XML services, and here is the entire header going and response coming back. So here is the XML call which is going back to the server. Now, if the same person is browsing around and hit to this particular form, now you can see this particular form is auto submit form, and what I have done, hidden parameter where a name is less than $XML version, and then in the value I have injected rest of the XML block. The entire rest of the XML block is in next section. So when someone comes to this particular page, what is going to happen is it is automatically the form will be submitted, and when form gets submitted, name will be taken. It is XML1, XML1 will be configured. So what you have going back is the entire XML stream generated from the dynamic form will hit to the backend web services to a CSRF. So over here, as soon as someone comes to this particular form, which is a cross-site, is entire application is running on some different domain, and you will hit with this particular XSRF, and order is placed at the backend. So this is the way you can dissect the XML, dissect the traditional form and generate the XML request. Okay. And over here you have a JSONRPC with CSRF. What I'm doing over here is there is a .NET based web services running at the back. You have ASMX. Over here the entire reference, so this particular JSON stream is coming back, and I'm overloading the function object, and I'm overloading the function object, taking the cross-site parameters and sending it to the target machine. This is the way CSRF is possible with XML stream or a JSON stream. Both of the stream can be possible.
A few more minutes just to cruise through it, and we got started a little late, but we got to get.
Okay, 6 is information leakage. Look for fault code. We will have information leakage with that. Broken authentication in session. .NET Web Services has a session. It's possible to manage session in a web services. So if someone is spoofing the traffic, pretty much it can get the session ID, and the traditional stuff can happen to the web services as well. Crypto, if you're using WSE or you're using WS security, there are some crypto issues which can crop up. Or if a web service is called going backend over AJAX without SSL, then it is possible to leakage in a communication channel. And failure to restrict URL access. We have like a URL access restriction over here. What we have is in WSDL file, you can have a method restriction. If you have admin method which is published on a WSDL, then anyone can make this method call. the way it is possible to have failure in URL access call. Next thing what you can do is you can do a code analysis on the web services. So scanning the code base, identify linkage, method signature and input, look for SQL, LDAP or XPath calls, and then try to identify the vulnerability. So over here, there is a tool called app code scan, which I'm scanning the entire source code. So what I'm doing is I'm selecting .asmx file, which I want to scan. I select the entire folder which I want to scan, where my entire source code is residing. So I'm selecting that, and I'm selecting the rules which I want to run against the entire source base. So over here are my rule set. What I'm doing over here is in the ASMX file, I'm looking for web method call. So I get the entire signature for ASMX file. I'm looking for whether it is session, the web services is session enabled or not. Then I'm looking for public functions. I'm looking for system web services dependency, which I can identify that this particular file is running with the web services at the back end. And then I'm looking for file and select. And then I run the scan, so I get entire information over here. This particular DVD is for ASMX file, we have web method, public string. These are the three methods. One method is actually running with a session string. Which you can see. Now what next I can do is I can trace the parameter. So I do my tracing on this with the tool. I trace each parameter back to the source, and if it hits any select query or something, then I can identify that it is a vulnerable. This particular web service is vulnerable to SQL injection or such. So this is the way you can identify a source code.
Take about 1 minute to wrap up.
Okay. And finally, what you can do is over here you can use the iHTTP module and defend your web services. There is a small utility which I wrote called Web2Wall. So you can use this, and particularly you can defend XML stream hitting to your web server or application or a JSON stream. So then you can load this ASMX. You can load as iHTTP module. It will go into your HTTP application set. You will get HTTP request and response object handler. So you can pretty much filter the traffic going in and out. And then what you have to do is just you have to load the DLL into your application. It will be up and running. So quickly I will show over here a demo for it. Over here is the application source code for this module, which is making the regex checks. I'm grabbing different pattern over here, and over here what I have is start listener and go for the invoke call to the get code, and I've blocked ID parameter. I'm just making my rule is such a way that it is looking for the symbol, and if the symbol is corrupted by any of the streams, then it will come up with the error. So if it's hit the IBM, then it is fine. So I'll get a code for 2532 for IBM, but as soon as I go for a single double quote, I got a system error. So this particular error is generated by iHTTP module, .NET based iHTTP module, which will generate this error. So you pretty much can defend your XML stream using this. So that's pretty much it. So conclusion, web services can be vulnerable to various attack vectors. Footprinting and discovery are start point for web services stuff. Scanning and auditing can help finding holes. Fuzzing is also important. You can nowadays you have whole different application streams which is hitting to your services level. Top 10 Owasp attacks which are traditional attacks, are applicable to all web services based services as well. Scanning code for web services is another important aspect, and web services firewall like IHTTP module, or if you're using Apache, or More Security has those XML tags